So this is some rough guidance on how to create a mask set for a contact aligner for 4-inch wafer in Magic. So I'm going to show you the top view, and since there's a lot of features that Magic will try to do design rule check, it'll actually take a long time. So actually turn off design rule checking, because with a lot of the veneer scales, I'm doing things off grid, and I am, violating design rules, which sometimes is inevitable. All right. So so I've turned that off. If you don't, sometimes it crashes. So I'm just going to open up AA top 2 mask fit. Okay. Let's see if I can just zoom in a little bit. Oh, that's fine. So anyway, we have all these cells, and these cells are test structures. And the way I did it is I just I did a grid and just had it place the cells on rows and columns, and then drew a circle, a 100mm circle, and then deleted what I didn't want, and added the logo, the alignment marks, and the benefactors' names by hand, plus some process windows, and then the solar cells. All right, so if you want to see what's inside one, you can just hover inside, press S, X, and now you can see a particular cell. I put a box around it, Control Z, and there's a solar cell. V brings me out. So here's just another cell. I'll select it, X, into a box, Control Z. And so all these cells are labeled with a column and a row, like Excel, D5. So when you're testing the transistors, you know which, you can trace it exactly. And then we have various veneer scales and other test features, not too important for this talk. But here we have just banks of transistors with various widths and lengths, and something called offset, which is important to a 2-mask design. We can go into that later. But the way this worked is I had a Tickle program take this cell that I'd kind of done by hand. Right, these I just I drew these features by hand and then added them as a cell. And then wrote the identifier and then saved it. So I took a generic file and then just all the rows and columns that I wanted, I just put in, I just wrote that. Now these transistors banks were generated automatically and then placed in these 4 areas. So this was done in a rush, and my documentation to myself wasn't very good. But to try to figure out how to kind of make a cell and write letters and numbers to identify it, okay, is really what it's about. So I just want to show you So I'm going to load in a Tickle file. And I believe This is the one we want. Okay. Okay. So these cells already exist, so it's essentially, I'll just stop it here. But anyway, if you look through the code, I'm drawing these pads, right, the end diff regions. Okay. And I'm adding in a label for the gate, source and drain. The body isn't connected for the two mask, and then I add in these veneer scales because offset's really important. But what's going on is we have the width, and we have the length, and we have the offset. And these are the cells of the actual letters. All right, and I think because the program is still running, it's not letting me like highlight it. But anyway, so it's creating all these cells. And so, you know, it's adding the number 2 or the character 2, character 0 for 2.0. Excuse me. 20 for 20. So 20, 10 is 10, and 04 is 4 microns. All right, that's the offset. So that's kind of what you want to do with your solar cells, is have a solar cell with numbers printing out. And let's see. So I'm just selecting X, and you can just see what's underneath. All right, just for the curious. And something I discovered because I was in a rush, this is actually the Y direction, and these things should have been flipped. So, you know, we try to get better. So now let's go look at the code that generated that. Make sure this is the right one. Okay. So in Tickle, you have a kind of a function defined, a procedure. It's going to be called cell design. You have length, width, and offset, and that'll be fed in. And so then, just to keep it straight, I'm setting the length of the NMOS to L, the width of the NMOS to W, and then this offset parameter. And then I'm setting a cell name, right, that it's going to be width by length, offset mag, and then I'm going to load that in. It's not really loading it in, it's just creating the cell, right? And a lot of this now is just like, if I recall, this is just because it ends with a paint metal 1. It's drawing the pads according to an algorithm, and a lot of this it's just dimensions and drawing and how I got the transistor to draw automatically. So like if I'm painting an end diffusion, now we're into creating the transistor. Again, not important to this discussion. All right, I'm connecting things up with wires. Okay, so now, okay, so I want to place the G, the S, and the D here every time. So what it does is it draws these pads, it draws these end diffusions, that's the gate region, and then it's connecting automatically to these regions. Right, but now I want to place this. So I'm, dimension x1, y1, x2, y2. It's just the box where the letter D should go. So I put a box here, and then I get the D letter that was created elsewhere. Now, it could be that I don't actually have to have the correct dimension of the letter. You might be able to put like a 1 micron box, and it'll just align it where you want it. But that's why I'm calculating out, the actual box where the letter would go. And then so the same thing, I set the dimensions of the S, and these are all fixed because it doesn't change from transistor to transistor. And then I get the G. All right. Now a little trickier here is because now I want the number. All right, so I'm just not very imaginative. I had a letter S represent the width, and then the width is actually 2 numbers, right? If you come down here, everything is 10, 20, 40, 60. So it's not like I can, or at least I don't know how to place 10 unless I made the number 10. So what it's doing, let's come back here, so that the first C and D, I'm not quite sure why I called it that, but I take the first index spot, right? So WN, if it's 20, the first index spot is 2, and then D, the second index spot would be 0, and then I just set these X1 and X2, and now this is how you get the number which you just pulled out to go into a file name that you can call. You need these brackets, okay? So that means substitute whatever was in position 0 here, whatever was in position 1, and that's how you would get the number. You load in the number 2. All right, so you've just named it. Then you do the dimensions. The dimensions are fixed and just done experimentally, so that and I'll just quick refresher. Right. So this would be, we're looking at width, and that would be the index position 0. That would be 1. For length 0, 1. Offset 0, 4. Right, and so these dimensions of the 20, 10, 04, positions are fixed. So that's why they might be programmable, but they're not varying. So what it has to do is it breaks the number 20 up into 2 characters and places things character by character. Now, yeah, if you could create, let's say, the number, if you wanted to do the number 1000 or even 10,000, you would have to take, let's say this was 1,000. I would have to take the index of each position where the number was in the string. Right, so if I had 4 digits, I'd have to have 0, 1, 2, 3, 4, and have these variables, and then set these labels to mean the number in question. Again, these dimensions are just where we put the numbers, and so now we have a box, dimension x1, dimension for the W, okay? And then we get that cell, right? Which it's those curly brackets allowed us to parse a number and turn it into what we wanted. And then we do the same thing for x2, right? Which would be here. And I didn't make a procedure out of this, so I just went straight in. Now I just copied it over and said, now we want ln. So you take the first position, second position, right? Then these dimensions will be slightly off from where the other one was. And then you have that. And now, let's see, the last one, we're just doing the offset. Okay. So I'm, there wasn't like an easy way, like a word processing program. I am placing every number, every individual number, because I thought that would be more generic. Now, what you can do sometimes is have a program write a word and then save that whole word as a cell and then place it wherever you want. Okay. Then I want in the veneer scales. And yeah, I probably should just, it's the beauty of this is I said I put them backwards. Well, I would just put the X and the Y, reverse it, and it probably would fix it. Now, how does all this work? It works at the end. Okay, and then it saves the cell name. So set L values, 10, 20, 40, 60, 80. So again, these are all strings, and this is two characters, two characters, two characters. I set the W values, right? And then, yeah, for each X and L values, for each here. And now I just call cellgen. And yeah, I probably should have had it for each Z in offsets and had the various offsets, and it would have done it all at once. But I probably did the 1 micron offsets, saved everything. I could have been more efficient. But that's probably right here at the end is that you're cycling through your solar cell dimensions, right? And I take those and right, and just to make sure that I don't overwrite anything, right, I have the L and the W's get set into LN and WN, and then it actually, you draw the transistors to and offset to those dimensions, right? But then when again, the question is grabbing the letters, right? So I set the string to 10, let's say. First character goes in, second character goes in, you label these X1, now you've got the file name, and again, those curly brackets. Sorry for repeating myself, but it took me a long time to figure that out. I think this is like maybe even 2 years ago, right? And then you get each individual cell. So if you look at now you're doing, it might be easier to use words benefactors, and so which you have set I, the index is 0, set L, list benefactors of the MPL. So now I have a list, and it's like, it looks like it's a word, but it's really just a string, and then you have spaces in there. And so for each word, right, print the word, go through, right? And so it's Anyway, I'm going to leave it here because I'm not quite sure where it's actually placing the characters. So maybe maybe that was something, because this looks a little better. Like I have word 1, word 2 for each character, split the word, cell name, and so I'm just going through and getting each, because this just goes to the screen, I think. But here I go and get the actual letter, and you place it, and so you do word 1, and then you do word 2. Let's try words. Okay, so I have a test. I have a list. Yeah. I have to figure that I have to go back because I don't see where it, I know this worked, but I don't see where it's actually printing the letter to the well, let's just, I realize this is probably a little bit longer. I'm just going to do words. Just cancel that. Words MPL. It's working. All right, so F, and you can see MPL faculty, and there's everybody there. So that does work. Words. Yeah, so there I'm getting the cell name. So that's, I'm doing each letter as I go through. Okay. It'd be nicer, like I'm kind of doing it the hard way. Should make a procedure that goes through each thing. Anyway, that should hopefully be enough to get you started. And I think, yeah, how to read the number, right? You know, you're trying to convert a dimension, and it's you use the curly bracket is one way.